Okay, November 2019, paper 2, variant 1. Question 1 is actually cancelled because the answer would be C, a micrometer screw gauge, but it had been removed from the syllabus, so we can just cancel out this question. Question 2, a light object is dropped from rest. It falls a large distance vertically through air. How can the motion of the object be described? As it falls down. As it falls down, the acceleration cannot be constant and it can never be increasing. The acceleration could be constant if air resistance was ignored. If air resistance was ignored. Decreasing acceleration and then moving at a terminal velocity. Yes, this is correct. The acceleration is never increasing. It's either constant if you ignore air resistance, or it would decrease if there is air resistance. Question 3. A car travels at an average speed of 60 kilometers per hour for 15 minutes. How far does the car travel in 15 minutes? How far does the car travel in 15 minutes? Well, first of all, you need to convert the 15 minutes into hours by dividing by 60. You'd have 0.25 hours. To find the distance, you'd say distance equals speed times time. Okay, speed times time, which is basically 60 times 0.5. 0.25, 60 times 0.25, which is 15 kilometers. Which quantity is a force due to gravitational field? Definitely it's the weight. What is the mass of the air in the room? If you have the density and you have the volume, so mass equals density times volume, which is basically 1.2 times 5 times 4 times 3. So the final answer would be D. Question 6. In which direction is the resultant force on the car? This is a car moving in a circular path, therefore the direction would always be towards the center of rotation. Towards the center of rotation. B. Um, Question 7. This meter ruler is pivoted at one end. The ruler starts to rotate in a clockwise direction. A clockwise direction. Therefore, this direction would, this moment would be greater than this moment. P times A is greater than Q times A plus B times the total distance all the way to the pivot, which is D. Question 8. Which statement gives a complete description of any object that is in equilibrium? In equilibrium, there is no resultant force and no turning effect. Okay. Object X and object Y collide and stick together. What is their velocity after colliding? Well, this is a classic case of impulse, or instead of impulse, we can say of two bodies colliding together. Object X is moving towards the right, which has a mass and a velocity, so we can say that this is u1, okay? And Y is moving towards the left, which has a velocity of u2. He did not state the masses, but he said that the masses are the same. They have the same mass. They have the same mass. Can I solve this question numerically? Yes, I can solve this question numerically. What do I mean? Yani, how can I solve this question numerically? You can just assume any number. You can assume any number for the mass. Let's take an easy number. For example, 5 kilograms. Okay, let's say that each mass of uh, um, these balls is 5 kilograms, or just 1 kilogram. If you say that the mass is 1 kilogram for each, so 1 kilogram, okay, that would be the easiest mass you could use for this question. You have object X and object Y, both of them are moving in opposite directions. So if X has a velocity of 5 meters per second, then Y has a velocity of negative 3 meters per second. Negative 3 meters per second. After they collide together, we will add both masses. How so? We can say m1u1 plus m2u2 is equal to capital M V, in which capital M is the summation of both masses. M1u1, so 1 times 5, so 1 times 5, plus 1 times negative 3, which would be equal to 2m, 2 times 1, which is 2, 2m. Let's write it down. M is equal to 1 plus 1 because we said that the mass is 1 kilogram to V. Now we can just find the final velocity. Now the final velocity would be equal to 2 is to V, and V is 1 meter per second. V is 1 meters per second. Should it be to the left or to the right? It should be in the positive direction. The positive direction was to the right. The positive direction was to the right, and therefore the correct answer would be B. Okay. Question 10. Brakes are used to slow down a moving car. In which form of energy is most of the kinetic energy converted as the car slows down? As the car slows down, most of the kinetic energy is thermal energy. A man carries 20 tiles from the ground to the roof of the house. Each tile has a mass of 1.2 kilograms. The roof of the house is 15 meters above the ground. How much work done? How much work is being done? You can just use the gravitational potential energy. Gravitational potential energy would be equal to mgh. So basically 1.2 times 9.8 times the height 15, and then you need to multiply this by 20. You need to multiply it by 20. Why? Because he has 20 tiles. So the total energy would be 3,600 joules. A car is moving along a straight horizontal road. The car has 1.6 megajoules of kinetic energy. The car accelerates for 20 seconds until the kinetic energy increases to 2.5 megajoules. What is the minimum average power developed by the car for this acceleration? We need to find the power developed during this change. During the change, how can you find the power? Basically, power equals energy over time. Energy over time. So basically, you're just saying that it's 2.5 mega, which is 10 to the power of 6, minus, you want to find the difference, okay, minus 1.6 times 10 to the power of 6 over the time taken, which was 20 seconds. So this would be around 45,000 watts, 45 kilowatts. Question 13. The pin is pushed into a wooden board. How do the pressure and the force at the sharp point compare with the pressure and the force on the flat surface? The force is the same. The force is the same. Why? Because you're pushing with the force from both sides. It should be the same. What about the pressure? No, the pressure on the sharp point, at the sharp point, would definitely be hundreds, if not thousands of times larger than the flat surface. So the force is the same, but the pressure at the sharp point would be greater. It would be C. Why? Because as you decrease the area, the pressure increases. An object is 20 centimeters below the surface of the liquid. The density is 1200. What is the pressure? Pressure equals rho gh. The height needs to be in meters, so it's 0.2 meters. 0.2 meters. So the final answer would be around, if you say rho gh 1200 times 9.8 times zero point 0.2, which is around 2400 pascals. Which statement about evaporation is correct? The most energetic molecules escape from the surface and the temperature decreases. The temperature decreases. A bubble of gas is formed deep underwater. The bubble has a volume of 40 centimeters cubed and the pressure inside the bubble is P. Volume and the pressure. The bubble rises up through the water, the volume increases to 56 and the pressure becomes 100 kilopascals. Can I find the initial pressure P? Yes, P1 V1 equals P2 V2. To find pressure, it would be P2 V2 over V1, which is basically 56 times 100 kilopascals over 40. The final answer would be around 140 kilopascals. And to be honest, for this question, you did not need to solve it. Why? Because you should have said the pressure would increase. The pressure should increase. The only pressure which has increased is D. The only pressure which has increased is D. So for this question, you don't need to actually solve anything. Question 17 has been removed. Question 18, a liquid turns into gas. So this occurs only at a particular temperature. So this is boiling. This is boiling. One end of a copper rod is placed in hot water. It's placed in hot water. Thermal energy travels along the rod to make the other end warmer. What is the behavior of the copper at an atomic level? At an atomic level, this is a copper rod. It has free moving electrons. So free electrons at the hot end gain energy and move towards the other end, colliding with atoms along the rod. Along the rod, as they move, they transfer this energy. Okay, D is actually not wrong, not right. Free electrons at the hot end gained energy from the hot water and moved directly towards the end. No, they don't move directly towards the end. In the process, while moving towards the end, they start to collide with the atoms, and therefore the whole rod starts to get heated. A surface is made so that it is a good source of infrared radiation. Which surface is not suitable? A good source of infrared radiation. Good source. So the only poor source in these answers would be a surface that is painted white. Question 21, a transmitter and a receiver. This transmitter is sending waves, okay, and the receiver needs to receive these waves. How can the waves reach the receiver? Not by refraction, not by refraction. Why? Because if you say by refraction, this means that the waves would go through the hill, okay? They would go through the hill, refract, and then exit through the other end, which is wrong. No, they need to diffract around the hill. They need to diffract. Okay, when they diffract, how can I increase the diffraction? You need to think about it this way. How can you increase the diffraction? By using a longer wavelength. By using a longer wavelength. Question 22. Which is the actual time? This is a clock this is the image of a clock in a mirror. The image of a clock in a mirror. What is the actual time? You need to reflect it. You need to laterally reflect it. So this is at the 15-minute marker, and this is actually at the 7-minute. Okay, 7 hours. So it's actually 7:15. It's actually 7:15 because you need to reflect it, laterally reflect it. A converging lens is produced, okay, or produces an image of object O, which position produces a virtual image. A virtual image, then it needs to be A. Why? Because the object needs to be closer to the lens than the focal principal focus. Word is missing. It's increasing what? Increasing the wavelength. Why? Because the radio waves have the longest wavelength. Question 25. Which row gives a possible value for the speed of sound in ice, water, and steam? In ice, it's the fastest. Why? Because it's solid. Okay. In water, it would be a bit slower, and in the steam, it would be the slowest. D. In question 26, a steel bar is placed. This question is cancelled. Why? Because you need to magnetize or demagnetize, which has been removed from the syllabus. Question 27, a plastic rod is rubbed with a dry cloth. The rod becomes positively charged. The rod becomes positively charged. This means that the rod has lost electrons. Positively charged, meaning that it has lost electrons. Question 28. How much energy is converted in 2 minutes? How can I find the energy? Energy equals VIT. VIT. So 2 times 2 times the time, which is 2 times 60. 2 times 60. So it's 480 joules. VIT. Question 29. The circuit shows a component X, which is a diode. Component X is a diode. Question 30. What is the correct order of resistance from the largest to the smallest? Largest would be in series. So we have three of them in series, and then two, and then X would be the least resistance. Why? Because if you have resistors in parallel, then the resistance would definitely decrease. So it's Z, Y, X. Moving on. Question 31. A circuit contains a cell of an electromotive force of 2 volts. Electromotive force of 2 volts. What is the reading on ammeter P and what is the reading on ammeter Q, on voltmeter Q? The total current is 2 amperes. Total current is 2 amperes. As the current moves through the wire and at this conjunction, what happens? First resistor receives zero point 0.5 amperes. First resistor receives, first ammeter, I'm sorry, receives zero point 0.5 amperes. Therefore, the second ammeter would have 1.5 amperes. Why? Because the total current has to be 2. The total current has to be 2. So if the first one has zero point 0.5, the second one would be 1.5. That's it. You just minus 2 minus zero point 0.5 is 1.5. So the current is 1.5. What about voltmeter Q? The total voltage is 2 volts. Total voltage is 2 volts. If the first voltmeter reading was zero point 0.5 volts, then the second voltmeter reading would be 1.5 volts. Why? Because the total voltage needs to remain constant. The total voltage needs to be 2 volts. If the first reading was zero point 0.5, then the second reading is 1.5. Again, all you did was 2 minus zero point 0.5. So the answer would be A. Definitely, this goes without saying that question 32 is cancelled. Okay. Question 33. Where must a fuse be connected in a mains electric circuit? The fuse has to be connected on the live wire only. On the live wire only. Question 34. A student investigates the output voltage induced across a coil of wire by a bar magnet. When will the induced voltage have the greatest value? How does it have the greatest value? When you slowly move the bar, when you move the bar stationary, or you leave the bar stationary? No, definitely not. Quickly removes the bar? Yes. You need to increase the speed of this motion quickly. At rest, definitely not at rest. So it has to be quickly moving. Question 35. There is a current in a wire. The direction of the current is out of the page. Out of the page, therefore, you need to use the right hand rule grip. Right, okay, hand rule grip, not Fleming's right hand rule. Out of the page, so to be B. A is definitely wrong because you have some arrows going in one direction, some other arrows going in another direction. So it's definitely wrong. C and D are of electric fields, not magnetic fields. Question 36, diagram 1 shows a coil of wire P, and diagram 2 also shows the coil of wire Q. The difference between P and Q is what? Is that P is connected to a slip ring while Q is connected to a split ring commutator. A split ring commutator. For a motor to work normally, you need a split ring commutator. For a motor to work normally, you need a split ring commutator. So this is the diagram that will actually rotate. This is the actual rotation. So P, okay, if you say, for example, A and B are wrong. Why? Because it will not continuously rotate. It will not rotate continuously. It will only rotate for a quarter of a cycle, for only a quarter of a rotation. So definitely, if you want it to rotate, okay, for in a continuous motion, a continuous cycle, you need a split ring commutator, such as in diagram 2. Okay, so does it turn clockwise or anti-clockwise? How should I know? Using the current, okay, and then using Fleming's left-hand rule. Fleming's left-hand rule says that the index finger is the magnetic field, direction of the magnetic field, which is pointed to the right. Okay, it's moving from north to south. And then the current in the right hand part, and the right hand part is moving kind of out of the page. So on this side of the coil, it would move upwards. Therefore, the other side of a coil will move downwards. This rotation is an anti-clockwise rotation. It's an anti-clockwise rotation. So it is C. Which diagram shows a possible structure of a neutral atom? Definitely it's A. The protons and neutrons are in the nucleus. Question 38. The scattering particles of thin gold foil provided scientists with evidence. What particles were used? The particles were the alpha particles. Question 39. A diagram shows a beta particle being directed towards the poles of a magnet. In which direction will the particles be deflected? The particles will be deflected, or how can I find the direction of these particles using the Fleming's right hand rule? The beta is using what, يا شباب? It's using Fleming's right hand rule. Fleming's right hand rule. So Fleming's right-hand rule, you have north to south, the index finger, which is directed downwards. The second finger or the middle finger, which is the direction of the beta particles, direction of the beta particles is to the right, And therefore the thumb would be directed out of the page. It would be out of the page. Fleming's right hand rule for the beta particle, Fleming's left hand rule for the alpha particle. Why are some radioactive sources stored in boxes? Okay, why are they stored in boxes made from lead? Definitely because lead absorbs emissions from the radioactive sources. Okay.